Okay, so today's notes are on standard to vertex form. It's our third lesson, but it's section 4-2. Our content objective is to rewrite quadratic functions in vertex form from standard form, and our language objective is to use the correct terminology to describe quadratics. So again, we're going to start by refreshing on what the forms of a quadratic are. We talked about this last lesson, but it comes into play again. So standard form is y equals ax squared plus bx plus c. Last lesson we talked about vertex form, which we know is y equals a times x minus h squared plus k. And we've also worked with factored form earlier this unit and last unit, which is y equals a times x minus p times x minus q. And right now we know how to go, or we've practiced going from standard to factored. We can go the reverse way by redistributing or FOILing out. Here we could do a similar thing where we just expand our squared terms and expand out to get to standard. So today what we're going to practice is getting from standard to vertex form, because we can kind of interchange between the other, or from vertex to standard, or factored to standard, or standard to factored, but we don't know how to go from standard to vertex yet, so that's what today's notes are on. So to start this out, we're going to talk about our axis of symmetry. As we know for vertex form, our axis of symmetry is x equals h. So for vertex form is x equals h, and then today what we're learning about is standard form, and the vertex, or the axis of symmetry for standard form is x equals negative b over 2a. So that is our equation for our axis of symmetry, which is also the x value of our vertex of a quadratic. So if we use this formula, we can get the x value of our vertex, then find our y value of our vertex, which will give us our vertex form. We'll practice that in a minute, but before I go any further, I want to explain where this comes from, so it's not just random letters. So we're going to address why that works. Why does x equal negative b over 2a? And so what we're going to do is show how we'd get this in our standard form from our vertex. So we're going to start with f of x equals a times x minus h squared plus k, which is our vertex form, and we're going to expand it, because right now we're going to go from vertex to standard form and then see how it aligns. So if we expand it out, we get a times x minus h times x minus h plus k. If we FOIL that out, we get a times x squared minus 2hx plus h squared plus k. So again, it'd be x times x squared, negative hx, and then positive h squared, and the middle terms combine to negative 2hx. So we use the FOIL method for that. And if we continue on, we're going to distribute our a in. So I get ax squared minus 2ahx, lots of variables, plus ah squared plus k. And now this is aligned with our standard form. So I know there's a lot of other variables mixed in, but we can compare this to standard form to get our a, b, and c values. So if I look at this, I know a is equal to the coefficient of x squared. So in this case, a is just a, which we'll talk about more in a second. B is going to be the coefficient of x. So the thing that I'm multiplying by x is negative 2ah. My c value would be my last part. So c is equal to ah squared plus k. So again, I'm comparing it to ax squared plus bx plus c. And the coefficient of x squared is a, coefficient of x is negative 2ah, coefficient, or the constant c would be ah squared plus k. At this point, I know that since I want the axis of symmetry, or the x value of my vertex, h is the x value of my vertex, so I can use this equation to solve for h. So I'm going to use this equation to solve for h. So I have b is equal to negative 2ah. I'm going to divide both sides by negative 2a. So I end up with negative b over 2a is equal to h, which is, again, as we know, the x value of our vertex or our axis of symmetry. So that is why it is our formula for standard form for our axis of symmetry. Because if I rearranged my vertex form into standard form, that is what the h value would become. All right, make sure you write down any questions about that, but now I'm going to go on to an actual example of how we're going to use this to turn a standard form into a vertex form. So our example, I want us to determine what is the vertex form of y equals 2x squared plus 10x plus 7. And so to do that, step 1, I'm going to identify a and b from standard form. So if I'm looking at this, I know my a value is 2 and my b value is 10. I'm not worried about c right now, only because my formula negative b over 2a only uses b and a. So then step 2, I'm going to solve for h with the equation h equals negative b over 2a, or x equals, you can think of it as h for the x value of the vertex, but it is an x value, so you can think of it as h or x. So I'm going to write x because we're going to use it as that in a minute. So x is equal to negative 10 over 2 times 2. If I solve that out, I get negative 10 over 4, which is equal to negative 2.5. So I have negative 2.5 from my x value of my vertex, but as we know in vertex form, we need the k value for our y value of our vertex. But our y value of our vertex is going to be given by this x value. So what we're going to do, step 3, we're going to substitute into our x value into the original equation. To solve for y or k, depending on how you're thinking of it. It's going to be specifically the y value of the vertex, but it is a y value. So I'm going to plug in my new x value I just solved for. So I have 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. And when I solve that out, I get y is equal to negative 2.5 squared is 25 over 4, which simplifies to 13.5 minus 25 plus 7, which simplifies to negative 5.5. So now I have my x value of my vertex, I have my y value of my vertex, and I can plug it back into vertex form. So step 4, I'm going to substitute into vertex form. And some of you might be wondering, what about the a value of vertex form? And one thing that's going to be useful, one note, is a is the same in all forms of a quadratic. Or if we've fully simplified and factored or fully written out standard form or completed our process for getting vertex form, a will always be the same value. So I can write it as y equals, my a value is still 2. So 2 times x minus negative 2.5, that whole quantity squared, plus negative 5.5, or as you guys can write more simply, y equals 2 times x plus 2.5 squared minus 5.5. And that is the vertex form of that quadratic. All right, we're going to do one quick check and then we'll be all done. So I want you to determine what is the vertex form of y equals negative x squared plus 4x minus 5. So try that one on your own really quickly. I'm going to go over it now. So I'm going to start, my a value I see is negative 1. My b value is 4. So I say x is equal to negative 4 over 2 times negative 1. So 2. If I simplify that, I get negative 4 over negative 2, which is just positive 2. So when I plug that back into my original equation, I have negative 2, that quantity squared, plus 4 times 2 minus 5. One thing I want to note is the 2 is squared separate from the negative, so the a value is outside the parentheses squared. So I get y is equal to negative 4 plus 8 minus 5, which simplifies to y equals negative 1. When I plug those all back into vertex form, I get y is equal to negative, so the negative a still stays in front, x minus 2 squared minus 1. And that is my vertex form of that quadratic. All right, make sure you write down any questions, comments, concerns you have on this stuff so we can go over it together in class.